Hello everyone, my name is Sandeep and today we are here with a new problem and it is a very interesting problem and the problem name is palindromic substring. I think most of the people solved it before, but for beginner it is a very good problem to understand. It is a medium type of problem. So in this problem basically we have a given string and we have to return the number of palindromic substring. So in that case we have two things, which means palindromic and substring. Palindrome means, let's suppose if we have a string, right? Let's suppose mom. If we read it from left to right, it is same, and if we read it from right to left, it is same. So that type of strings are palindrome. And if we take ABC, if we read it, it is ABC, and if we read it from right to left, it is CBA. So it is not a palindrome. And what is substring? Substring means a continuous part, which means, let's suppose if I have a string like A, B, A, C, and D. In that case, BAC is a substring, ACD is a substring, but BCD, BCD is not a substring because here we are not considering A, which makes it discontinuous. Now what we have to do, we have a given string and we have to find the number of palindromic substrings. It means, let's take an example of A, and in that example, we have substring like A, B, C, A, B, B, C, and A, B, C. And we can check whether A is a substring, a palindrome. Yes, because if we read it from left to right, it is A, and right to left, it is A. So it is a palindrome. B is a palindrome, C is a palindrome. AB is not a palindrome because if we read it reverse, it is BA. Then BC is not a palindrome and ABC is also not a palindrome. In that case, we have only 3 palindrome and we can return 3. Now let's see how we basically solve this. We can basically solve this using the same approach, which is, first, let's suppose if this is the string we can find all the substrings, and after finding all the substring as we do before, we can check whether it is a palindrome or not. Now how we can find the substring? So finding substring is very easy. We will make a pointer here and we will make a pointer here, and we can actually start this pointer at this position and we can move it like AA is a substring, then AA is a substring, AAB is a substring, AABB is a substring, and we can move everything and get all the substrings. Then we increment this pointer and start again from AA, then AB, then AABB, ABABBC, and similarly. And the time required in order to find all the substrings is big O of n square, and for all these n square substrings we have to check whether it is a palindrome or not. It is the right problem and right solution, but the time complexity is very high, which actually make our whole problem very time consuming. And for that we have to understand how we basically solve it. So we basically using dynamic programming in order to solve this. And in dynamic programming, what we do, we basically try to save the solution for sub problems and use those sub problems in order to find or make our code more optimized. How we can do this? Let's see. So let's suppose this is the string I have, and now we will remove each thing. Like if we consider A, because A is a substring, so this is a substring, and the remaining string we have is ABAD, right? Similarly, if we go and take AA, so AA is a substring, so we will take it and the remaining string is BAD. Now AAB is not a substring, so we are not able to consider it. Here A ABBA is not a substring, AABB AAD is not a substring, right? In recursion, what we do, we basically go through one thing. So you can see that we can take A because it is a substring, we can take B and the remaining is AD. Then we can remove A, now the D is a substring. Similarly, from here we can remove B and AD is a substring, and similarly we can remove A, then D is a substring. Now if you see this tree, okay, I will not write everything here, but if you see this tree, you can see this AD is there, this AD is there, this D is there, this D is there. So if we save, like you can see this BAD, If we solve this whole subtree and we get the number of substrings, palindromic substring, we can save it somewhere, and when we reach here, we can simply use that, and we don't have to write the whole subtree. And that's how we are basically uh, solving or saving our problem. How? Let's understand. So let's suppose at any point of time A, B, A, D, right? Let's suppose I have a solution somewhere that AB is not a palindrome substring. So we make it false. We make it false. Now let's suppose we are going to check for AABBA. Now the first thing we have to check is whether this character and this character is same, because for palindrome the first and last character should be same. Yes, it is same, but now for the between substring, which is the between that we have, we don't have to check each and every character. We can simply check whether this AB is a palindrome. If it is a palindrome, it means this AABBBA is a palindrome. But it is not a palindrome, we can simply say that it is also not a palindrome. Got it? Now we will see how we basically solve it. So here we have some condition, we have some base case. Let's understand this. Let's suppose if we have a string A. So this is a single length string, and it is obviously the only substring we have, and it is a palindrome, right? And another case, if we have a string like BB, in that case we can simply check whether the first and last character is same. If the string length is 2, in that case we can simply check whether it is a palindrome or not. How we basically solve it, let's understand while dry run it. So A, B, A, D, let me create a table. A, B, A, D. Okay. A, B, A, D. 0, 1, 2, 3, and 4. Similarly, 0, 1, 2, 3, and 4. Okay, now we can simply, what we can do, we can start from last and we can check from there and there. Now you can see that D and D, same character, we can make it true, and we also have a counter which is initially 1, and when we get something true we will increment it by 1, right? Now we will start from 3 and start from this 3 and go till up. Now you can see this and this character is same, we will make it true and also increment our counter by 2. Now we will move our pointer by 1, and it means AA, it means this substring which is AD. Okay, so let me write it D, right? So in that case A and D is not equal, so we have to make it, we have to make it false. Now we are at this point and we start from there. Got it? So what we do, we will check whether BB is equal. Yes, we will make it true and increment it by 3. Now we will check whether B and A, it is not equal, so we make it false. B and D is not equal, we make it false. Now A, now we will start from this A and A is equal, we make it true. Now A and B, it is not equal. Now A and A, it is equal. Now this is the point, A, B and A. Now this and this is equal. In that case, whatever the middle substring we have, we can check from these cells. So let's suppose A is at index 1, then 2 and 3. Now 1 and 3 index is done, and we have to check for medium in between, in middle substring. How we can check? we will increment this pointer by 1 and we will decrement this pointer by 1 and we will get the middle substring, which is 2 and this is 2. So for 2, 2 we already have answered true. If it is true, we make it true and increment it by 4. Got it? Let's move on. Then AD, it is not equal, make it false. Then AA, it is equal and increment it by 5. Then AA, it is also equal, but we have to find the middle one, which is 0 is incremented by 1 and 1 is decremented by 1. So it is 1 0, which is 1 0. Not 1 0, it is like 0 and 1. Yes, now it is a different case. In that case 0 and 1 means this string length is 2, and if this string length is 2 and the first and last character is same, we can simply put true. We don't have to find the middle because it is a single 2 length character and we need to check first and last, right? So we can increment it by 6. Now AB, in that case the length is greater than 2. Now AB is not equal, which is false. AA is equal, right? So here 0 and here 3. Now we increment 0 by 1, which is 1, and 3 decrement by 1, which is 2. So 1 2. So 1 and 2. It is false, so it is also false. As you can see, 0 to 3, which is AABA. So if AA is equal but AB is not a palindrome, right? Which we get from this cell. And similarly AD is not equal, so we make it false. And at the end we can simply return this counter. So we will start from last and go till up. So that is what we do in the code. Let me show you in the code how we can solve it. Okay, so this is the code. So first we create a DP of same string length and we start from last index and we will check. Here we will check if the substring length is greater than equal to 2. In that case what we will check the first and last character. If the first and last character is same, we will check in our DP matrix that the middle subarray, we will increment I by 1 and j is decrement by 1, and if the middle substring is true, we have to make first it's true and increment counter by 1, and if it is not equal, if it is not true, middle substring is not true, we make it false, and if the first and last character is not true, we make it false. Okay, I think let me give you an example. Example is A, B, C, A. So you can see that A and A is same. This thing is done. Then we will check for BC in between string. So you can see that BC is not a palindrome. So we get it false, and then we also made this ABCA as false, right? And in case J and I means we have two length string. Let me give an example. AA, yeah, AAA, sorry. So if the string length is 2, we have to check the first and last character. If it is equal, we will make it true, increment our counter. Otherwise we will increment it by we will make it false. And this is the last case where the string length is 1. Let's suppose it is A, B or anything. In that case we don't have to check because single length string is always palindrome. In that case we will increment counter by 1, make it true, and at the end we will return the counter. I hope you get this problem and you also like this, how we solve it. If you like this, please like, share and subscribe to your. Bye bye.